My name is Raymond Jacobus. I work with SMART chillers. Little background on myself. I've been in the industry for about 30 some years total, service industry. I've been working with the turbocore compressor and SMART chiller for quite some time. Well, turbocore compressor since 2003, and then I started working with SMART chillers in 2009. So I've been with them, been around their equipment quite a bit. So that's pretty much my background. I guess we're here to discuss your new chiller. I don't know how much you're up to speed on the refrigeration cycle. Get a show of hands. How many you guys we got? Okay, so I'll get basic then. It's basically a unit that chills water. And extracts water or extracts heat out of the water that's circulating through your building and rejects it into the cooling tower. So you've got two different heat exchangers. You have one for the chilled water side, the low side, then you have another heat exchanger for the high side, for the condenser side. So basically, you have a refrigeration loop that's contained in the equipment. You have water coming in and out. Both evaporator and condenser water. You've got a number of controls related to the refrigeration cycle. You've got an expansion valve, which separates the high side from the low side. So you have a high pressure side, low pressure side, which produces, it expands the refrigerant into the low side, it cools evaporates the refrigerant, cools the water, and you're good to go.
What's the refrigerant?
134A is the refrigerant, is what we're using. You've got the expansion, you got two turbocore compressors on this particular chiller. I don't know if you're familiar with the turbocore at all. But it's an oil-free compressor, so there's no oil in this chiller at all. So there's no oil management, there's no oil heaters, no pumps, no switch gears for any oil management at all. So it really cleans up this chiller quite a bit. So I don't want to catch anyone adding oil to this system because it's a contamination at this point. So, but the turbocore compressors are a marvel in themselves. They are completely self-contained, highly controlled compressors. They're centrifugal compressors, which is very similar. If you're familiar with a water pump, a centrifugal water pump, very similar design, where you're just taking a fluid from bringing it into the pump and discharging it through the pump. It's not like your typical air conditioning compressor where it's a positive displacement. You have you can have reverse flow through the compressor, basically, just like you can a water pump. So the compressor itself is completely controlled by electronics. It has a logic in the compressor that will actually levitate the shaft in a magnetic field, and then then it has a speed drive which will take the compressor from 0 to a maximum of 40,000 RPM. So it really has a very soft start, a 2 amp start, and a very slow start, which makes it very energy efficient, very low inrush. So you have basically the bearing design, and then you got the power electronics, which is part of the drive. Then you have another section of the electronics, which is control and safety. That will monitor the compressor. So you have a number of safeties built into the compressor. You got overcurrent, overpressure, low pressure. You've got temperature safeties, a number of safeties built into each compressor. So they're pretty much self-contained. They can be, and they self-monitor each other or themselves. and then so that's the compressor on its own. Then there's also a chiller controller, which combines the two compressors together. Or all compressors on this particular machine, you have two compressors, so it combines both compressors and monitors the chiller as a whole. So then you have a number of safeties in the chiller controller as well, which I'll refer to as the Kiltech controller.
You say this thing's wound up to 40,000 RPM, and it's basically floating in that magnetic field,
Mm-hmm.
and you have a power failure. What does it do to protect itself?
That's a good question. Well, as the compressor is spinning, there's a certain amount of kinetic energy in that shaft that's spinning. Well, as soon as the compressor, this is part of the logic, part of the safety in that compressor, as soon as it senses a power loss, it instantly changes to it goes into a generator mode.
Okay.
So it produces enough power to keep the capacitor bank charged long enough for the compressor to safely slow the shaft and delevitate the shaft, and it'll set down.
So hard shutdown isn't so much of a hard shutdown.
No, you can. Yeah, a loss of power is not a fatal incident to the compressor. No, it'll do go through a routine of a safe shutdown.
Doesn't it ride on bearings though too?
No, no, it rides in a magnetic field, so there's no mechanical friction at all. Yeah.
The motor itself, I'm just kind of thinking about this. Is it actually a three-phase motor, or is it something different, like a DC motor that
No, it's a
rotation dependent?
Yeah, it's a permanent magnet motor.
Okay.
So the shaft has got a very strong magnet. So the rotor of the motor is really just a magnet. And so what you have is you have AC power coming in to the compressor. It's rectified to DC voltage. So it's rectified to close to 700 volts DC. From there, it's fed into a speed drive. This is all contained within the compressor covers. So it has a speed drive, which does the switching of the DC voltage to a simulated AC sine wave. Yeah.
Okay. Three-phase?
Three-phase, yeah. 40
so it
volt,
is rotation
three-phase.
dependent. So if for some reason somebody reverses the rotation on this thing, does it protect itself on that?
Yeah, the phase is determined by the drive. So as far
regardless of the input.
Regardless of the input. So yeah, so if someone switches your legs on your disconnect switch, it's not going to make a difference.
Okay, cool.
Yeah. The drive will determine the rotation. And that's like I say, built into the compressor. Yeah. There's any other questions? I mean, we got. I don't have any visuals for you. Sorry. But yeah, most of the interface is probably the key for you guys. You know, for looking at the chiller and interacting with the chiller.
What's your biggest problem with these things?
Problem? We never have any problems.
Trick question.
There's no one given particular thing. It's Danfoss, the builder of the turbocore compressor, has done a fine job of quality control, and they have a pretty robust electronics. And it's been a number of years since it's been available to the general public, the compressor, and they've come a long way in the reliability of the compressor. The chiller itself really doesn't have many moving parts. You have an expansion valve and a hot gas valve, a level sensor, and some temperature sensors. And there's really no moving parts. You've got the two shells, which is just a shell with copper tubing in it, with water running through the copper tubing. So there's really not it's just a basic chiller. If you guys are familiar with any chillers at all or been around a chiller,
Basics.
It's a chiller with oilless compressors.
What's this staging sequence on it? Does it bring to When does it bring the second one in and shut the second one off?
That's all configurable. Yeah, it's part of the setup, the configuration of the controller, and it's really site specific. You know, it just depends on your application.
How was ours set up?
I don't know. I'm here for James Bottoms, who did the startup on the chiller.
Oh.
So it just depends on how he set it up. You know, he was here performing the commissioning, and but basically it's set up on demand. There's a demand override setting, so you get to a certain demand. From the get-go, you can start one compressor, two compressors at a time on initial startup. Just depends on your application again. So you can start multiple compressors when you begin your cycle. You first enable the chiller. You can then from there it's based on demand. So if you have there's a demand setting that you can put in there. So you'll sequence on the second compressor.
What is it looking at, differential in temperature? Or
It's based on demand, really. Demand, and there's a speed reference as well that could also bring in the second compressor. So, but basically it's on demand, and
well, what calculation is it using to know what the demand is?
it's part of the PID loop.
Yeah, but I mean, is it
control
looking
loop.
at temperature or what?
It's all based on supply temperature. I assume this is all supply water temperatures as a control that we're in. So again, I haven't not that familiar with your particular chiller, but most chillers are set up for leaving water control. So it's looking at leaving water. Right, except it was running at 42 degrees as set point. It's right at set point this morning when I looked at it. But yeah, it looks at set point. You have a control loop that is configurable depending on your application again, and what your requirements are. If you need fast response, or you can live with a slower response and a little drift on the temperature. It's better to have a slower response and just have a smooth operating machine instead of having it cycle on and off or stage compressors.
That's what it's doing right now. It's cycled on and off a lot.
Oh, does it?
Yeah.
Oh, okay. Well, that could be due to light loads.
Yeah, right.
Yeah. These machines, they do turn down quite well. So we'll have a look and see how it's set up, and when do you find it cycling?
Yeah, when it's cooler out, it usually cycles a lot.
Yeah. Okay. It's probably just not much of a load. I don't know what fan coils you have in your buildings. If you have the three-way valves or one bypass valve.
No, they took the three ways out and put just single valves.
So they're okay.
It's a two-way valve.
So two-way valves, and you must have a bypass valve out there somewhere.
No, it says primary, secondary too.
Oh, okay. All right. Oh, okay. Well, if your valves, it depends what's going on in the building. If you're losing demand or call for cooling in the building, and your valves close off, then there's your supply water is going to plummet, and the machine will react by shutting off. Yeah.
The unit itself is mounted underneath that rain cover.
Yeah.
Doesn't protect it from wind blown, whatever. Is that going to be any kind of issue in your mind?
No, I don't think so. I mean, it's built for outdoor use. I mean, it's shrouded in metal and covered. It's nice. You do have a cover over it. It should be fine.
How many have you seen outside like that?
There's a few. Yeah, there's a few. There's most chillers, especially large tonnage chillers, are indoors. That's pretty typical application in an indoor plant somewhere.
Mhm.
But there are plants that are outdoors.
What's the frequency of replacement parts for like the drive components and stuff? Is there some kind of schedule on that?
No, the only
I know when they first came out with turbo cores, they were talking about replacing the capacitors like every 5 years, or
right. Yeah, that's been
has that been figured out, or?
well, that's based on the capacitor manufacturer that Danfoss uses,
Right.
and they've actually revamped their their projection, and actually they say 10 years now on your capacitors.
But outdoors, because I mean capacitors are usually, the lifespan goes down based on heat usually.
I don't know any statistics on that. Yeah, it's a funny specification though, because if it's a 10-year lifespan in use, but if it's on the shelf, it's lower. It's like only a 7-year lifespan. So it's kind of funny that way, the specification. But yeah, I don't know. I don't have any information as far as outdoor applications. As far as I know, it gets warm out here.
Mm-hmm.
Yeah. I don't know. That's a good one. Always inquire, find out if anyone has any information on that. I'd have to go back to the capacitor manufacturer, I'm sure. Now, as far as maintenance on the chiller, of course, it's reduced maintenance because of the oil-free nature of the chiller. So you don't have to be concerned with oil pumps or filters or changing the oil periodically. There's no maintenance as far as the oil. So that really relieves quite a bit of the maintenance duties on the chiller. But still, every probably annually, brush the tubes on the condenser. It's just like any other chiller. You want to keep the tubes clean, especially with a turbo core compressor. They any centrifugal compressor, they don't like high lift situations. They go into a surge, which is reverse flow through the compressor.
Is that destructive to these?
No, not necessarily. I imagine it'd be destructive if it was really severe for a very long time. But these the turbo core compressor is monitoring the position of that shaft at all times. In fact, it's 100,000 times a second. It knows the position of that shaft, so it's very fast and very detailed and very close tolerance. So if you're into a surge and it gets severe enough, it displaces the shaft far enough, and it'll just shut down on a fault. So it'll come up with a bearing fault of some sort, of BMCC bearing fault, and it'll just protect itself and shut off. So unless it was allowed to do that for weeks on end, it should protect itself and be fine. The other maintenance items would be probably here, since it is an outdoor installation, the electrical cabinets, especially and each compressor has a line reactor, and if that's allowed to get dirty, there could be problems taking out fuses and things. You could get current flow to ground if it's allowed to get dirty. So there is a filter in the cabinet, and there's a fan in the cabinet as well. It blows, it circulates air through the cabinet.
Circulates, or does it bring in air?
It draws it out.
Draws it out. So it draws it in from conduits, or draws it in from?
There's a filter on the door. It's a louvered panel, and there's a filter on the door, and so that's something that you could probably look at replacing every 3-4 months, probably every 2-3 months probably. Out here you're maybe even sooner. It just depends on your here you're in pretty dusty locations, so it could once a month maybe pull that filter out, and probably annually I'd clean that cabinet out. I'd make sure that cabinet is clean.
Is there internal fans in the VFD that's on board?
Not on the VFD. Yeah, there is a fan, small fan on one of the soft start. We're on the
That's
soft
one of
start
the
board.
biggest problems we see is those fans going out.
Yeah.
So
Well,
is it replaceable, or is it?
it is replaceable.
Okay, good.
Yeah, but it really doesn't rely on that fan so much for cooling. Each compressor has a motor cooling circuit.
Well, what about the drive itself?
The drive itself does not have a fan
Okay.
on it, but it has a heat sink with a refrigerant circuit.
I see. That's how
Specified.
you're cooling it.
Yeah, that's
I gotcha.
that's how it cools. Yeah.
Oh, yeah.
I mean,
Just
without
step above, yeah.
without motor cooling, you're going to be in
Yeah.
trouble in a big hurry. It's not going to run very long. but yeah, each compressor is at full load. Each compressor is about a 2-ton load in itself, so to cool electronics in the motor. So it's quite a large load in its own. That's at full load, of course, and then but yeah, you need that's part of the things we'll go over when we go look at the chiller is the motor cooling circuit, and you should have a clear sight glass to the compressors on the motor cooling circuit. Yeah, any flash gas or any for any length of period anyway could signify a problem with the chiller and something that needs to be addressed. But yeah, it has heat sinks under the drive, and then also the refrigerant will flow over the shaft and around the stator and then over the shaft and then back to the suction of the compressor.
Hmm.
So there is cooling applied. Yeah, maintenance is just basically cleaning the electrical cabinets, the compressor power electronics. Probably would be good to inspect that annually as well. Word to the wise, when you go to isolate a compressor electrically, you shut it off and you want to leave it off and not take any covers off for at least 20 minutes because of the capacitors. They do hold the charge for quite a long while, and it's 700 volts DC under the top cover. So there's a side cover as well that houses the control electronics. You can safely remove that while the compressor is even running. It's not going to bother anything.
Some drives have a LED that stays lit until it's died down below the safety threshold voltage.
There is an LED
Yeah.
in the control cabinet. There's a board, interface board for each compressor. There is a green LED light on that board, but it goes out fairly quickly.
You still have high voltage.
Yeah, it'll actually go out within a minute and a half, and but there's still power on that compressor.
It's good to know.
Yeah. I don't know. Any other questions you want to shoot at me, or?
The check valve chatter?
Yeah, they do chatter. Yeah.
Yeah. All of them?
Yeah, on occasion, yeah, you'll hear them chatter. Yeah.
Oh, on occasion?
Yeah.
Every time.
Yeah.
So I mean, is that
That's normal.
is that because two are starting up at the same time, or it'll do that on one?
You may hear that on one compressor starting. It's just that that check valve is spring loaded. Does have a spring in it, and these are soft start on the compressor, so they wind up very slowly, and you get to that threshold where you're just overcoming the spring tension, and you may get that it may bounce a couple of times before it actually blows that check valve open and goes to run. And you when you sequence on the second compressor, when you have one compressor that's running, and then you bring up the other compressor, it has to overcome the lift, of that compressor. So that's part of it too. When you get to that point, that critical point where you're just overcoming the lift of the other compressor, then it'll chatter. You'll hear some chatter in that check valve. Now, the check valve is very robust. It's the out of all the check valves I've seen applied to turbocore, this one seems to be the sturdiest. We had very few problems with the check valve. So it's alarming to hear it chatter, but it's part of it's the nature of the beast. You will hear that on occasion. Yeah. Okay. Yeah. This is the chiller, guys. We've got the two compressors on top. They're actually under a weather cabinet, weather seal, if you like. So you can remove that while it's running. It's not going to be a problem. Don't be afraid to remove the cover that's on there now. It's the covers that are actually attached to the compressor that could be a problem on especially the power side. We've got this is our we've got, well, the two disconnects, one for each compressor. You can isolate the compressor electrically. You can also isolate each compressor from for the refrigerant system. So you can have basically isolate the compressor electrically and from the refrigerant system to work on it. So you can continue to run the chiller even although you may have a problem with one compressor. You want to service one compressor on its own and not shut the chiller down. You can do that. So you've got a number of valves on here to allow you to do that. In the cabinet, there's pretty much there's not a lot in there. You've got we could open up the cabinet a little later and show you, but you've got the power coming in to the disconnect switch, and then you have a line reactor in the bottom of the panel, which is downstream of the disconnect switch, and that then you have a feed to each compressor or to the compressor. So there's really on these doors, you see we've got louvered panel to keep the well, this is an eyebrow to keep the weather out, but you've got louvers underneath here with a filter behind there. So that's the filter that you'd want to periodically change out or clean. Probably the more often you change that filter, the less dirt you'll find in the cabinet itself. But probably every once a year when you do your annual, I'd certainly go inside that cabinet and clean it out. Make sure it's not accumulating too much dust, especially if you get a little dirt, little dust, and some moisture. Then you could have some issues with blowing fuses or having issues electrically. Nuisance problems, basically. So that's to each compressor you have a disconnect switch. Then you have the control panel. On the front of the control panel is a display. It's all it is just a display. It has nothing to do with operating the chiller, except for that it's just an interface. So we can interface the chiller. So you could pull that out, take it home. It's not going to affect the operation of the chiller. It's still going to run. You just won't be able to see it locally. So that's a display. That's your interface. We can go through that in a little bit, and I'll show you all the different views in the controller. But inside the panel, we talked earlier about the interface to each compressor. These green boards here on the left-hand side of the panel is you've got two there, one for each compressor. You notice there's a green light upper right-hand corner of the board. That light, if you lose power to the compressor, that light will go out. So if you have a compressor that's not running, you can eyeball that light and say, well, geez, there must be a problem with the power on my compressor. I don't have light. That green light is out. So it could be a problem with the compressor. You check the feed, or could be a fuse, could be anything. So that's our interface to the compressors. We've got the main controller for the chiller is this box up here. That has all the logic for the controller for the chiller. I'm sorry, and it's in communication with the entire chiller. So it's in communication with each compressor through the Modbus link. So we're actually communicating to each compressor. Also, this is the I/O board, the input-output board for the controller. So it's basically the arms and feet of and the hands of the controller. So it actually has the analog inputs, outputs, digital inputs and outputs. So that's the actual board, and it's in communication as well with the controller. So it's all done through Modbus, through 485 Modbus link. So that's the basics in the panel. That's the major components. We've got a couple of other boards here on the lower left, and those are driver boards for the expansion. Well, one's for the expansion valve, the other's for the hot gas valve. So that's electric valves that are driven off the controller. Sends over a 0 to 10 volt signal, and actually sends a signal to these boards, but these boards will actually do the driving it has the power to run the valve, but it's still under control by the controller. You've got a couple of interlock relays that they do have LEDs on them, so they do light up when they're energized. You do need to they do need to energize before the chiller will run. So that's something to eyeball, something to look at if you're wondering why it's not running, why your chiller's not running. Control voltage is well, we've got 24 volt AC to the I/O board. We've got 20 volt DC. This is actually a 110 volt to 24 volt, I believe it is, DC output to the controller. So that's another power supply for that. We've got another power supply here for the display. Yeah, and there's also for the two expansion valve boards, we have 24 volt AC supplied to them as well. Yeah, one of these cabinets probably houses the fuse for each board. So we can I don't know if we can shut the machine down and open those up today or not, but I don't know if that'll affect you guys, your operation. But if
the disconnect mechanism and open the door, keep it running.
I could, yeah.
But that's just a question. Can you do that?
It can be done. Yeah, yeah. If it's not violating any safety rules.
It is, but you know, the reality is we have to do that sometimes.
Okay. Well, I don't want to be caught on videotape actually violating. Yeah. All right.
That's the question.
All right. And see myself on YouTube.
No,
this is what you don't do.
We have our flash rules that we have to go by.
Yeah. Okay. Well, I don't want to violate any of those rules, so especially not on video.
We got them on tape, right?
Yeah. Okay. Any questions so far, guys?
Got a surge suppressing receptacle up there?
No, I don't believe. Well, let me see. No, I don't believe it is. Maybe it might. Yeah.
Okay.
It doesn't have your typical reset on it though.
Yeah.
It's don't come out and plug in your rotor hammer, you know, because it's only like a 1 amp service. It's basically meant for your laptop or any other low power device. Anything under 1 amp. We want to walk around the chiller a little bit. And I'll show you the flow switch. This is typical of both the chilled water and condenser water. You can get a close-up of the flow switch. It's a digital flow switch, so it'll it's actually analog digital, so you'll have a number of LEDs that'll march across your analog indicator. That'll be your analog indicator, but it's actually it's proof of flow, you know, yes or no. So it's basically a digital output, and it's you get a nice visual reference. Yeah, it's actually
Arrow on top there.
yeah.
Line on the pipe.
Yeah, its flow is this direction, and that's the direction indicated. So as the flow increases, your LEDs will light all the way across. Then there's an amber light there. Which is actually set point. So you get below this amber light, and it'll indicate no flow situation, and also that LED will turn red, go from amber to red. So it's there's no moving parts, so it's very very dependable. Same thing on the chill water side. You got the same type of switch on the chill water side. All right, we walk around behind the chiller. All right, we rolling? All right. What we have is first off, we've got a level sensor. This senses the level in the condenser barrel. You may or may not see a level in the glass. There is a sight glass there. You may or may not see a level. Just depends on the level of the where it's set at, really. But you know, 1 or 2%, you can be above or below that sight glass, so you may or may not see any level in that sight glass. But basically, this machine is looking at level in the condenser, and it'll open or close the expansion valve to either drain. If the level's too high, it'll open. It'll empty some of that liquid into the evaporator, or if the level's too low, it'll pinch down and stack more liquid in the condenser. So that's a sensor. It's feedback to the controller, and in turn the controller operates sends a signal to the boards that are actually operating the valves. This is the expansion valve. So this is our separation between our high side and low side. So we're taking high pressure refrigerant, expanding it across this valve into the low pressure side, and that's where we develop our evaporation and cooling. We've got another expansion valve. It's the identical valve, but it's in use here as a hot gas valve. So we're just a bypass valve. So we're taking high pressure gas off the top of the condenser, and when needed, the hot gas valve will open and put a false load on the evaporator. So there's a low load situation. We'll put that into effect to keep the chiller online if need be. Of course, if it can only do so much, and it may cycle off the machine if the temperature gets too low, it'll cycle off. We've got our motor cooling circuit is here. It comes off the bottom of our condenser, so it gets liquid. We want a solid column of liquid at all times in this line, so it gets liquid right off the bottom of the condenser. So if there's any liquid in this condenser, it's going to be fed into this line. It comes up to a manifold, which has probably can't see it on the video, but you've got a sight glass here on the side, and you want to see that full, typically all the time. If it's a very low load situation, the compressors are spinning at a very low RPM, you may see a little flash gas or a little bubbles in there, but don't be too concerned with that. It's more when you're under a higher load, full load, not full load, but a higher load situation where you're going to want to see that sight glass full. If you see it starting to bubble and flash, then there could be a problem with the chiller, either loss of refrigerant or loss of valve control. Yeah, that gives you a peek inside the evaporator, and you can see the tubes, and that's about it. Yeah, you might see a little refrigerant coming above the tubes. If you take a peek in there, and well, it's useful at times. If you're having motor cooling issues, you see you're not maintaining a solid column of liquid for your motor cooling, and you go, well, geez, why don't I have refrigerant in my condenser? And you look through the sight glass and you see it's like full of refrigerant. Well, you know where your refrigerant went. So it's all stacked in the evaporator, not being held in the condenser. So at that point, I'd investigate why my valves aren't keeping the refrigerant where it's supposed to be. So yeah, that's an indicator. It's a good tool. It can be useful at times. This is the check valve that you hear chattering on occasion. It's cast iron, very robust. It's a piston type. So it has very, very few issues with the check valve. Even though they chatter, don't be alarmed. It's kind of a normal operation. So you'll hear them chatter, especially on startup, especially on sequencing between each compressor. Yeah, it is. Yeah, double duty. Yeah, so so you can use it as an isolation valve. It has a stem on it that you can close that secure the refrigerant on the high side if you needed to open the compressor. Any questions, guys? What's that?
How are you controlling hot gas?
How are we controlling? Temperature is the main control. Is temperature, so you can set it so many degrees below set point. It'll open, yeah. So you can set it up that way. It just depends on how it's configured. It depends on your application, on how you want to run the chiller in your application. What's required for your application. Speak right into the microphone.
So with the yellow tape, the blue tape, what is that? What are those?
I don't know. That's not factory, or that doesn't really.
We brought that up to the contractors. What are they? They're relief valves. Oh. So it's a
If the relief valve open, that tape won't stay there very long. Yeah.
Yeah, these ones aren't even work because you kind of hit somebody right in the head.
Yeah, it's probably not. Yeah, I don't know. It is what it is. But I guess it's to keep debris out of.
I think they're gonna.
Yeah. A lot of applications you see like a plastic cap maybe on there, that to keep the dirt out, but it'll.
I'm hoping they're gonna stand them somewhere else.
Just a short pipe and an inverted U would probably be fine. Any other questions, guys? You got if you have to do any work on any component that has isolation valves, it's really a nice machine.
Part of the design
This, part of this, since this is located outdoors, it's shielded. Yeah, normally it would just be Armaflex is what you normally see in a typical chiller installation. Yeah. Any questions, guys?
They were using installations like this one looks like it fell off the ship or something.
I gotta take a
No
look.
offense or anything, but
No, I don't know. Yeah, that's you don't want to throw that out. You'll need that.
it looks like used, right?
No, I don't know. Yeah, it
What's this valve for?
looks like a textured. Looks like the texture on my wall there. I don't know what that is.
Turn them around like when you're gonna clean them. You drain it and then pull that piece off, and then you'll see the piece.
Any questions on the components, guys? Anything you see? The valve. Which valve? We're walking back this way.
On the suction side, is that just an isolation valve, or is it connected to
The butterfly valve that you're looking at. Yeah, the butterfly valve on the section. That's for isolation. Yeah, so you isolate the compressor from the rest of the system. So yeah, it's just a 90-degree turn on that valve, and you will isolate it.
and back where the installation's at?
Okay.
Automated? No. It's an isolation valve. Uh-oh, Gary.
That was probably on temperature, yeah? Yeah, we're right at set point. So, I don't know, we can go through the controller. It's hard to see here, the glare is so bad. I don't know what's better. This is the home screen on the controller. Features on this, the nice thing about this, well actually every window we look at will have the we got a little box on the top here. It's our status, and on every screen that we go into we'll always have this bit of information. So we have the status of the chiller right now. The state is running normal. Got the date and time. We've got entering water and leaving chilled water. So right now it's pretty close to set point. It's 46.5 coming in and 42.6 leaving. I think our set point is 42. Yeah, so we're pretty close to set point. So this is our home screen. We got a couple of analog dials, which are just kind of fun to look at. We got a percent demand and percent full load kilowatt. So this is right now we're only at 19% full load kilowatts. So we're just barely got a very light load on it at the present time, and our demand is 35%. You can see that. We've got another indication of the entering and leaving water. We got set point here, which is 42. We've got leaving water, which is 42.8. Entering water 47.7. Same on the condenser side. This is our condenser water. Entering is 77.6 and leaving is 75.8. So we've got all that information there. Down, we've got controller messages on this page. Very helpful when you're trying to understand the logic of the controller. So if you can see that, our last event was sequence off state compressor number 2. So every move it makes, it'll come up with a message. So you're curious where we're at with the controller, what stage we're in. We can get some clue or some hint of what the what the logic, what the thinking of the controller is. So that's a nice feature there. And then of course you can scroll down, and you can see what happened previously. You've got a number of buttons on the right-hand side. These are all different views of the chiller. So we got a chiller overview page. No, can't do that. You only use this on a touchscreen, which is what you have. So you'd actually hit it here. I'm going to have to use my mouse though.
Yeah, that works.
I'm going to have to use my mouse. Same status window on top, so you always have that information. It's nice to have there. Quick reference. Again, it's kind of repeated the same information we've already learned about. We've got evaporator info, set point, entering and leaving, condenser info, entering and leaving. We've got our power input, where we're doing full load amps, percent demand. We've got a little bit of information on compressor 1 and 2. We've got, if you can see that, we've got speed and IGV position. So it's just we've got a lot of information we can pull from the compressor. This is just a little snippet of what we can pull. And then you've got the graph of the chiller itself. Right now we got a couple of LEDs on each compressor. One's green, one's red. Of course the green one is the one compressor 1 is running. Number 2 is offline at the moment, so it's red. You see up here we've got, it'll tell us that green is running and 2 is ready to run. So that's important. Now if the compressor was powered off, the change would say offline. So it's good to know. So it's ready to run. It's ready to run. So it's all systems are go. If there's a problem with it, it'll indicate it here that maybe it's locked out, but it'll indicate what the problem is here, why that compressor is not running. But as long as it is ready to run, then you're good to go. You've got some chiller information. You've got saturated evaporating temperatures, EXV position. condensing temperatures, and hot gas position. Again, you got chill water in and out, condenser water in and out. A lot of information. Very important too is this input status info here on the bottom left-hand corner of this page. We've got a number of items here listed. We got chiller enable, chill water flow, condenser water flow, compressors ready, anti-cycle timer done, and overstart set point. These are in order for the chiller to, you enable the chiller. In order for this chiller to actually operate, all these have to turn green before it'll start. So that's something to good indication for you guys. If you're fretting why your chiller's not running, come over here, take a look, and if something's not green here, then that gives you a direction, points you in a direction where to look. You know, if you don't have an enabled state, you'll say, well, why don't I have an enabled state? Well, it's maybe go back to your home page, and maybe my auto, maybe it's not set to auto, maybe it's set. If you can't do that. You click that, and you see you got choices. You got override off or override on. So you can maybe somehow it got switched to override off. So that's why it's not running. You can always override the BAS system by going override on. As soon as you do that, then this chiller enable state will turn green, and that part of the starting sequence is satisfied, and you'll be ready to go. As long as you have chill water flow or condenser water flow, as long as all these are all green, it'll take off and run. See, right now we'll probably stage on another compressor soon. We're over our set point, so that's a good indication for you guys. So if you're wondering why your chiller's not running, and that's a good place to go to get a clue. So we can go back to our home page, and then go to compressor page. So this gives us a lot more information on our compressors. This particular view, we have each compressor in a vertical column side by side, so you could scroll right across and see, you know, that they're balanced, that they're doing pretty much the same reading. So you can get a quick reference that they're between one compressor against the other. You've got some analog dials over here. You've got chiller amps, percent RPM, which is, well, we can talk about that in a little bit. We got percent demand.
They give you RPM?
Pardon me?
They give you RPMs or just percentage?
Yeah, no, yeah, our RPMs are displayed here on the compressor column, so you can see what the actual RPM is. You can there's a minimum RPM and a maximum RPM. Minimum RPM is our surge speed for the centrifugal compressor, and maximum RPM is the choke speed for the compressor. So if you're not familiar with those terms, of course, minimum, if you go below minimum speed, you're in danger of surging. So you'll have backward flow of refrigerant through the compressor. So from the suction side to the discharge side, instead of that's the way it's supposed to go. The reverse flow from the discharge to the suction side. So that would be a surge.
What is that speed, do you know?
It changes depending on the running conditions. So that's part of the lift of the centrifugal, and depending on the condensing temperature and the saturated suction temperatures, those speeds change. So it's each compressor has its own map envelope that it runs under, and it's been mapped, so it knows at which speeds, under which conditions, you can safely run at. So those speeds will change. So you'll see the minimum, maximum speed here, and the percent RPM is just the difference between the two. So the higher percentage on the RPM, the closer you are to choke speed. Choke speed is maximum speed, and it's the point where you could apply more power to the compressor, but you're not going to pump any more refrigerant. So you're wasting energy at that point. So there's no point to apply more power. So that's your maximum speed. So you're not going to do any more work over that speed. So there's no point in applying more power. Okay, any questions on that? Any? So that's pretty much the outline of this page. But then you can open up compressor 1. Yeah. You click the number 1 here, and you get an expanded view of the compressor. Gives you even more information. What to look for here would be our cavity temperature, which is running at 106, and our inverter temperature, which is 77. That's our drive, our inverter. So right now it's running at 78 degrees, which is pretty much normal. And our cavity temperature is 107, which is normal as well. Our critical fault on the inverter is 175 degrees. That's the point we'll trip. Actually, we get into an alarm. There's an alarm setting and a critical fault setting. The alarm setting is just the point where you're getting close to your critical fault. So the compressor will react by slowing down. So it'll try to slow down, try to stay online. But if it can't, and you continue to increase the temperature to the critical fault limit, then it'll shut down and do a reset. It'll automatically reset at that point. But there's two different levels. So you got the alarm level, and then you have the critical fault level. And that's where you'll actually shut down in the critical fault. And there's a number of alarm points and critical. In fact, they're all got alarm points and critical fault points. But that's what you want to look for. Those are two indicators that you want to keep an eyeball on: is the motor temperature and inverter temperature. You've got discharge superheat, saturated suction or discharge temperature, saturated. Then you got suction superheat. Then you have saturated suction temperature. So you've got quite a bit more information here. You've got compressor hours as well displayed here. So it's kind of nice. So you can navigate through here. You can close that. You can open this one. Oop. Same kind of deal. And you can move it over that way. Move it back. So, all right, back to the home page. We'll do that. And then got system overview. This is our next one. This is the evaporator view. This is our chiller barrel. Again, we have our status window up here. Always have that on each page. You've got evaporating temperature, water temperature in and out. You've got the delta T, which is the difference in temperature from entering to leaving water. Right now we're running 4.9, 5 degrees. Saturated refrigerant temperature. We've got the evaporator approach temperature. I don't know if you guys are familiar with that term. Approach temperature, that's the temperature difference between leaving water and our saturated refrigerant temperature. So, you know, the most efficient would be 0 degrees, so it'd be the same, but no chiller will do that. So, but we get very close, so it's very efficient. Typically what you see is temperatures anywhere from 0.5, 0.6 where it's running right now, all the way up to maybe 3 degrees. during full load conditions. You might see it as high as 3, but typically it's much lower than that. Shows active set point, and then here you've got chiller enable set point, 43.2. So it looks like roughly 1 degree above set point you're going to start. The chiller will start. Then you have a stop set point of 40. So 2 degrees below set point, you'll start to cycle compressors off. You get 2 degrees below. I don't know if we're controlling pumps with this controller or not, but you can see we have the LEDs here that'll give you indication of which pumps are enabled.
So it starts 1 degree above set point?
Yeah, it'll start. Yeah, 1 degree above set point.
Is that normal? Is that the default? Or?
No, it's whatever application suits your needs. You know, whatever you need. If you need
Is there a delay on start, or?
Yeah, there is a delay. Yeah,
Between start and stop?
there is a delay on start. So there's a recycle timer that'll time out.
And what's that for that?
About 180 seconds, typically. Yeah. But yeah, that's all configurable. If it's not meeting your needs, that can be changed. Yeah. So that's just how this particular machine's set up. So we have over on the right-hand side, we've got expansion valve information. We've got level set point, which is 23%. So that's our target level. And right now the level is at 24.8. And then we have a little expansion valve position, which is 23. So you can get an idea what your expansion valve is doing, where your level is from this page. You can view the condenser by you click this tab here, and we go to the condenser view. Pretty much the same information, but only for the high side. We've got condenser leaving water, condenser entering water, delta T, which is our difference in temperature from entering to leaving. We've got saturated refrigerant temperature. We've got our approach temp. Again, that approach temp is a little higher than the evaporator. You'll probably see that anywhere from 2 degrees all the way up to maybe 5 degrees, but typically not more than that. If you're getting higher approach temperatures than that, then there could be some fouling issues or something going on with your condenser. So it might be time for service. Something you want to eyeball, something you want to log when you do your chiller logs. You've got, of course, if we're controlling the fan, I don't know if we were controlling with the Kiltech controller, but this has the capability of controlling the fan, your set points, and also condenser pumps. We can control condenser pumps if need be. Again, we have expansion valve information. We have level, set point, and actual level, and expansion valve position. So back to the home page. We've got a trending page. So here got water in and out, chill water in and out, condenser water in and out, and yellow line is actual set point. Then you have power here. Right now it's set for a scale of 6 hours. You can double tap that and set it for 1 hour. And hit OK. So you can get an hour, what it's been doing for the hour. You can go to one of these side arrows. And the same for compressor demand, same for the PID output. That's on the expansion valve. So this is this is a graph of our expansion valve, opening and closing. So you can double tap that, put it on 6 hours or 1 hour instead of 6, hit OK. That gives us a better view of what our expansion valve has been doing for the last hour. Okay, back to the home page, and this is our alarm page. Right now they're showing no alarms. You can click here, the little hourglass, and we're set for all dates already, so there's no alarms have been recorded. Not since the display has been turned on and off anyway. So that's it'll hold alarms here until you cycle power on the display. It doesn't mean you've lost your fault information, your history. You can always retrieve that history from the Kiltech controller. It holds 12 months of data, consecutive 12 months of data. So you can, that's part of your, I would recommend part of your routine maintenance every quarterly to pull that information out of your controller so you have a running history. In case for any particular reason you might lose that history, you have some kind of a backup. But it does store information for 12 months. I'll show you how to retrieve that in a little bit. That's pretty much it. We've got an input-output page. You know, this shows you all your inputs and outputs. This is a digital input screen we're looking at here, and it's everything without the graphics. So it's all the same information without the graphics. So you see your chill water in and out, condenser water in and out. There's a number of spares as well. But it's all the information that we've been going over without the graphics. And then we can scroll over. We got digital outputs. So it's just another reference. Analog outputs and temperature inputs. So it kind of puts everything for diagnostics. It's nice to have everything side by side on one page.
Does it come up red if it goes outside of its?
No, not necessarily. But you will, in your messages, you may get an indicator, or in your alarms, you may get an indicator, but it won't turn red. What will happen is it's more of a service tool, but if you do override a section of the system, you do a manual override, it will show up red on your. So if you do go through this and you do see something's in red, it's probably been overridden and should be addressed. Nothing should be overridden not for any length of period anyway, any length of time. So that's pretty much it, guys. Any questions?
If you're going to show us how to download that 12-month period?
Yes. Yeah, it's fairly simple.
How do you reset it?
You had a question?
No.
Oh, okay. Well, if you want to take a look, you want to come around this side, and there's 4 USB ports that we can choose any one, and you take your flash drive and you plug it in there, and we can go back to the view of the computer if you like, or is that a better view for you, or? All right, hang on. All right, enough of that. Yeah, let's go back and look at the computer screen. So I plugged in my my flash drive to a USB port, and here it popped up with a what do you want to do screen, and we can just cancel this out because we don't want to go into the files, not on this display. But what we'll do is go to our settings tab. All right, we're on our home page, so we'll go to our settings tab, and we'll just plug in 1, 2, 3, accept, and this puts us in our settings. And what we want to do is scroll down here to data log. So you want to touch data log, and basically we got a tab here, copy all files. And if you notice, we got a blue bar that runs across, and we're copying all our files from my USB. Now it's done. So it's that quick. So that's all it takes.
Now, does that erase?
No, no, it does not. No, it's held for 12 months, 12 consecutive months.
There, you downloaded it to the data stick, and then how do you reset that, or wipe out your screen? How do you downloaded all that information?
You don't.
You don't.
No, you don't. Yeah, it'll just roll itself over. So it's always there. Yeah. So you should have 12 months of data. So basically, I'll take my my USB drive, my flash drive, plug it into my computer. It'll come up in a CSV format, Excel spreadsheet, and you'll see all the data there. So then you can, from there you can take off and do whatever you want with it. Grab whatever you want, look at whatever you want.
Once the file is full on the onboard unit, it just starts to get rid of information as more information comes into the screen.
Right. Yeah. So if this has been running for 12 months, April will be a new month, and so you could only go back as far as last March. Yeah. Right. So any other questions, guys?
Can you hook up the USB port to it and get the same information, or it has to be Ethernet?
No. It's just I don't need a laptop at all to gain. I just use my laptop so we can see it better for the video.
No, like say if I want to hook up a tablet, can I use the USB, or do I have to have the Ethernet cable?
To connect to the chiller?
Yeah.
No. You need the Ethernet cable.
Okay.
Yeah, to connect to it. That'd be the way I'm connected to it. You need the Ethernet cable. Okay. Any other questions?
How do you reset the alarm?
Oh, okay. That's a good question. We didn't cover that at all. Typically, everything is set for automatic reset. So if you do suffer a fault, it will automatically recycle itself. It has a fault timer, which is about 180 seconds. So it'll run through that fault timer. Once that time's out, then you go into a restart delay timer, and then which is about another 180 seconds, and then the machine will just automatically, as long as all those LEDs are green in the system overview, as long as we've got everything in green, it'll restart itself and take off. Yeah. You can suffer a lockout fault if the compressor does reach a critical fault on high pressure or three-phase overcurrent. The compressor will, or there's another, if it sees a condition 3 times in 30 minutes, like an over temperature of the inverter fault, if it sees that 3 times in 30 minutes, it will lock itself out as well. So you come to the computer screen or the display on the chiller, and you see that one of the compressors is not ready to run. It actually says lockout. This probably may have had some kind of a critical fault. That there's only 3 that'll take it out. And to reset that is to actually cycle power on the compressor. You have to wait till that LED goes out. Typically just leave it off for 5 minutes, then bring power back up, and then it should reset itself and take off. As long as that fault is cleared, it should take off and run fine. Any other questions? The capacitors, yeah, the capacitors, they're integral of the compressor itself. Yeah. So you have to take off this weather cover, and take off the top, and they're inside there. If you see a picture of the compressor, you can see the shape of the capacitors on the one side, on the discharge side of the compressor. Yeah. They're all integrated into the compressor. They're built in. Yeah.
Good?
Anything else? Good?